Today we're looking at solving linear applications. And we're going to have the linear equations that we had in there yesterday, but they're not going to give me the equation. I've got to come up with one from a word problem that they are going to give me. So to start us off, I want to just go through some word problem strategies with you. I'm actually just going to let you read these, and you can pause the video if you need to. Okay, so my first example I want to work today is find 4 consecutive even integers such that the sum of the first 3 exceeds the 4th by 8. So making sure I understand this problem, I'm just looking for 4 numbers that meet this criteria. So my answer is going to be 4 numbers. So first thing I'm going to do is I want to find out what x is. I want to set x equal to something. X is what I'm looking for. I'm looking for integers here. And so I'm just going to let x be that first integer that I'm looking for. I could go on down and set and get the second integer, third integer, and fourth integer, but I think it's going to be easier if I just work it like this. Okay, so when I look down here, I see that I just see a couple key words here. The sum of the first 3. Okay, the sum of the first 3. Well, if x is my first one, the sum means I'm going to add. I want to add to it the next even integer that I have. Well, I'm not sure what the answer is going to be, but suppose it was 10. The next even integer after 10 would be 12. So I'm just simply adding 2 to any integer, and it gives me the next even integer. So this is the x plus 2. And then the next even integer after that, I just take the original one, and I add 4 to it. So this would be the sum of the first 3 integers. Okay. Now the fourth integer is going to go over here on the side by itself. It'll be x plus 6. And it says it exceeds the 4th by 8. That means that this left side is 8 units larger than what the right side would be, this fourth integer. So if I add 8 to that fourth integer, I should get both sides to be equal. Don't let the parentheses throw you off. I'm just combining my terms here. So I'm going to get 3x plus 6 equals x plus 14. I'm going to subtract x from both sides, and I get 2x plus 6 equals 14. Subtract x, 2x equals 8. So x is going to be 4. And remember what x was. X was just my first integer. The problem asked me to find 4 integers. So if I just simply add 2 to each one, I get 4, 6, 8, and 10 for my answer. You can definitely check this and plug it back in. Let's try that again. I'll help you set this one up. We'll pause the video and have you work it out, see if you can match what I got. Anytime you see these number problems, I think it's always good to let x be that first integer. But this time we're looking for odd integers such that 3 times their sum is 5 more than 8 times the middle one. A little bit more going on with this one, but I still see that we're looking for the sum of the 3. So I'm still going to be adding the first one to the second odd integer to the third odd integer. Well, this time they're odd, but it's not going to change anything, because even if my first odd integer is something like 11, to get to the next odd integer, I'm still adding 2 to get to 13. So this will still be x plus 2, and x plus 4. Now I've got to do a little bit more with it than that. It says that I need 3 times their sum. So I could just go through and just multiply every single one of these terms by 3, or I could just put a 3 out in front that I can distribute through in just a minute. I love it when a word problem gives me is. Is my equal sign. I'm just going to keep reading. I'm wanting 5 more than 8 times the middle one. The middle guy is right here. And so I would just solve this one as well. I'm going to pause the video, let you solve it out, and come back together, and we can see if we matched answers on it. And this is what I got, 3, 5, and 7. Anytime we're working with one of these and it has to do with geometry, I always think that idea of drawing yourself a picture would help on this one. It's going to be something basic, like in this case, a triangle. We have a triangle, and we know that one side of it is a third of the perimeter, the second side is 1/5 the perimeter, and the third side is 7. What is the perimeter? Again, this last sentence right here, this last part of the last sentence, that helps me know what I want X to be. I want X to be the perimeter of my triangle. I can just go through and label these sides. So it says that one side is 1/3 of the perimeter. So it's going to be 1/3 of X. And then the other side is 1/5 of X. And the last side is just 7. So what we know about perimeter is if I add up all the sides, it should give me whatever the perimeter is. So I'm just going to add up all the sides. It's going to give me whatever I need the perimeter to be. Seems popular from the homework I saw last night that we want to clear this fractions. And so to do that, I need to multiply by 15. Hopefully I can do some of this in my head. I got 5x, 3x, oh goodness, 105 equals 15x. So I put 15 through to the whole equation. So I get 8x, 5, 15x. Subtract the 8x from both sides. I get 105 is equal to 7x. Just undoing that multiplying by 7 I did earlier, and I get back to that magic number of 15 meters would be the distance all the way around. The last part I want to talk about is distance, rate, and time formulas. Hopefully you did some of this in your science class, but the basic formula is distance equals speed times time. Okay? Time is equal to distance divided by speed if I divide both sides by speed. So I can solve this for any of them that I need to. We can come back and reference this if we want to. So San Francisco to Honolulu, that is a long way. So this is 2,100 nautical miles. So I'm going to draw this. Didn't look at a map before I did this, but let's just suppose San Francisco is just a little bit further north than Honolulu. We have 2 boats that are going is 2,100 miles. So this would be something, a very easy picture that I can draw to help me understand the problem better. Okay, it says so we have if one ship leaves San Francisco at the same time another leaves Honolulu, and if the former travels at 15 knots, so this boat coming from San Francisco is going 15 knots, and the one coming from Honolulu is going 20 knots. It's wanting to know how long will it take the 2 ships to rendezvous? How far will they be from Honolulu and San Francisco at that time? Okay, so we have 2 different ships going on here. So we have 2 ships going 2 separate distances. D1 plus D2 equals 2,100. Where D1 is how far the ship from Honolulu traveled, and D2 is how long the ship from San Francisco traveled. Well, going back to my little triangle from the last slide, in order to find my distance, I just have to do its speed times its time. So I'm going to substitute in this D1. I'm just going to let Honolulu be my first ship right here. That first ship is going 20 miles an hour. That's its speed. And how long is it going this 20 miles an hour? Well, wouldn't it be great to know that? Because that's exactly what the question is asking, how long until they rendezvous. So I'm going to sit there and let that be my variable. In this case, I'm going to use t. The second ship, it is going 15 miles per hour. For how long? I don't know. And that's still equal to 2,100. So I substituted in my distances with speed and time. I'm going to be able to solve this for time. 35t equals 21. So I do believe that made it so t was, Plug this in real quick. 60. 60 what? Well, knots is a nautical mile. So it's a nautical mile. It's miles per hour. So this will be 60 hours. A long time. It's going to take over 2 days. That answers the first question, but it asks something else. It says, how far will they be from Honolulu? Don't let that throw you off. We know how fast it's going from Honolulu. If it goes at a speed of 20 knots for 60 hours, 20 knots times 60 hours, that will tell me how far it is. So it has to be 1,200 miles from Honolulu. I can do a very similar math with San Francisco, or I can just say, well, I know it's 2,100, so it has to be 900 miles from San Francisco. And so these, not necessarily this guy, but will be my 3 answers I'm looking for. Just to keep this video halfway short, I'm going to skip this next example. If you want to work it, please do. I'd love to check your work on it. I'm not going to play this video. I'll include it on the classroom site if you want to watch it. But the idea with this is that there's a guy washing a car it takes him 6 minutes to wash a car. And there's another guy, he's washing the car, it takes him 8 minutes to wash a car. How long does it take the 2 guys to wash the car together? And actually, anyone that doesn't know too much about math will say 7. That's what the young man says in this, and that's not right. I think to solve this problem, all we need to do is change our distance to car. And we still have speed and time down here. So if we know the first guy washes the car at washes the car in 6 minutes, we know his rate right here. He washes 1 car every 6 minutes, so that would be 1/6. That would be his rate. Now we get to add to that. He's going to go a little bit faster than that because the second guy is going to wash one car every 8 minutes. So their combined rates will be 1/6 and 1/8. 1 car per 6 minutes and 1 car per 8 minutes would be their rate. Now, if I multiply that, the question asks, how long will it take the 2 guys to wash the car together? So if I take their speed and I multiply it by their time, just like the last problem, it should tell me how long it takes them to wash 1 car. Or if I want to know how long it takes them to wash 12 cars, I could put 12 cars over here on the right side. Okay, so I'm going to go ahead and add this 1/6 and 1/8. I'm going to let time be t, and then there's a 1 up here. So 1/6 plus 1/8, that's going to be 7/24. Times t equals 1. Well, I'm just dividing by 7/24. The same as taking the reciprocal. So t has to be 24/7 minutes, which comes out to, what's that, 3 3/7 minutes. Which comes out to 3 minutes, I think someone told me earlier, 26 seconds. And that would be my answer. So kind of a fun problem. You go back and watch the video, and Mr. Feeney explains it.